Hi there, so I wanted to try something a bit different. Most of my videos are quite short and silent and there isn't much explanation, so I wanted to hopefully try and explain projects that I'd started to do more recently, and going forward would hopefully explain projects that I've done, so hopefully someone might find somewhat interesting. This project that I'd like to talk about is a watch prototype that I was working on that is based on the HCMS series intelligent LED displays from Broadcom. This is the back of the board, this is the front of the board. So on the back you have a DS3231 temperature compensated real-time clock which talks over I2C. Put up resistors are here. This is a coin cell backup for the RTC. This isn't required, but I didn't want it to forget the time if the main supply ever went flat or got removed, so I added this on. The fuel gauge IC, which is here, is a BQ27441, and then the microcontroller is an Atmega 328. This is programmed in over the Arduino IDE, and then there's a library as well which is used for this RTC. There's a library for the fuel gauge and then there's a library used for the LED displays themselves. It's a bit out of my league trying to do that on my own. So this is the shunt resistor for the fuel gauge. Power comes in here and this is ground. This is the charge LED. This is a 500 milliamp charger set to 200 milliamps because it's a 500 milliamp hour lithium polymer cell, and I wanted to keep the charge rate under half a C. So yeah, and this is a GPIO pin, or this LED is connected to a GPIO pin. Currently it's set as the wake up LED, so every time this wakes up, which is once every 2 seconds, this just flashes, so it's more like a heartbeat, just so I know the thing's actually working. And then on the front you have 4 buttons, the footprint for the 4 displays, a USB type B micro. I have 500 milliamps written on here because originally I was charging at half an amp because I was using a considerably larger cell, but I dropped it down due to size constraints, trying to keep it as small as possible. This is the SPI port, and then this is the serial port. I use the SPI port to program the bootloader onto the Atmega, so then I can use the upload program over serial with the auto reset. The actual display that I'm using is the HCMS 290X. I have it written on here 39 because the 39 series run at 3.3 volt up to 5 volt, whereas the 29 series are only rated from 5 volt down to 4.5 ish. But I have tested that and they do seem to work below 4 volts. I think 3.5 they start to get a bit finicky with display and stuff, but so far over the range that it's ran it's been fine, but they're not technically spec to run at it. What was it there? And then Dashable Design is just my name that I go under for the projects that I've done. So yeah, so this is just the board version of it, and then this is the completed version. So it's as small as I could it's as small as I could get it based on what I was using. So that's the top finished. It's got M2 screws to hold the top on with inserts in the corners. The actual that foam is just like electrical packing foam. I'm using it as padding because there's some hollow spaces in here. So this is the cell, lithium cell. So it's a 500 milliamp hour cell. This is just some fibre tape just to protect the back of the board from pushing on the cell and rubbing on the cell, and then just some more packing foam to fill in the voids. This thankfully sits down beside this in the space. So when you press the display button, it will wake up and display the time, for 10 seconds, and then it will display lithium status, so the date and time, and then now it's saying, so I've just charged this up, so the lithium is reading 4 volts. Obviously they top out about 4.2, but that's what it's reporting, and then the static charge is 100%, and then it goes back to sleep. In idle mode it draws about 300 microamps, or 0.3 milliamps. I have measured it a couple of times and it sits around that area. This has been sitting around for 4.5 weeks, and I check it once a day, and it was about 50% state of charge, so it does last reasonably well. If you were running it all the time, it would only last probably a couple of hours, because these draw about 100 to 150 milliamps continuously when they're displaying actively. So the other thing you can do is you can set the time with this. If I actually plug it in to charge, that will go back up to about 4.2 volts. So when you press the set button, you'll get the prompt set date and time. If you press the display button, you cancel it. If you press this button twice, so you press it again, you'll get now hours. So now it will ask you to set the hours. So if I set the time, so 20, and then it'll say mins for minutes, so it's 41. Set, and it'll ask you for the day, which is the 20th. And then the month, not too far, 4th, and then the year. It only displays the last 2 digits of the year, though it obviously assumes that you're in 2000 and something. So in this case 25 will be 2025. And then when you press set for the last time, it will say date and time set, and then pressing that will now display the correct time that I've just programmed in. So yeah, so they don't do anything else at the moment. It's just a case of it wakes up, displays what it needs to display, and it goes to sleep again. I have worn it. It's alright to wear. Bit of a pain, you've got a jumper on because it ends up getting stuck under your jumper. Other than that, it's alright. I do hope to try and shrink it, but I don't think I could get it much smaller. The other option would be ditch 2 of the displays, so you've just got 1 row with the buttons, remove the coin cell backup, and then put the microcontroller and the real-time clock more underneath the displays. There are smaller real-time clocks that could be used that are probably just as accurate, and also there are smaller microcontrollers. You don't need many GPIO pins to run this. There's 4 used for the LEDs, 4 for the buttons, and then 2 for the I2C that talks to the fuel gauge and the real-time clock. So yeah, and so these come in green, red, orange and yellow. I've managed to find the yellow version quite cheap, but I'm still looking for the other 3 colours. I have a wall version of this, which is just plugged into USB power. Because the fuel gauge is 5 volt tolerant, it will happily measure 5 volts without any issue. If I plug this in, so this is connected to a bench supply at the moment. So if I plug it in, again the board moves because there's no top lid on. So it's plugged in, and if I do this, at the moment it's charging at 190 milliamps. The voltage may have gone up. Yeah, see. So now this is actually measured, because obviously the fuel gate, charger IC is now trying to push power into the cell. So it's quite a small cell, so obviously removing it, maybe it'll wake up. yes, it's dropped back down now. So this is where it roughly sits all the time. From the multiple times that I have charged it, it sits at around 4 volts. I did miss off the resistor that tells the fuel gauge that the battery is inserted, so it might mess up the state of charge slightly, but the actual voltage measurement is correct. On the new version, the resistor is actually in place, so it knows the battery is actually inserted. And then on here, I don't know if you can see it, the green LED flashes every time it wakes up to check, so roughly every 2 seconds. So this is effectively when it's in sleep. You can't actually see the LED from the front because I didn't plan for it to be used, but obviously it does actually have a use. And then the lid that goes over the top. So yeah, the watch strap is just stuck in on the bottom. I did change the delay on the set time because it was getting stuck and sometimes just erasing the time without actually being able to set anything. So it also minimises the risk of you leaning on the button and then it randomly going into that mode and getting stuck. So these 3 buttons don't actually do anything unless you're in the program mode for the time. So yeah, so if you found that somewhat interesting, let me know in the comments, and thumbs up if it was half interesting. I do have a handful of other projects that I will start to go through. There are videos more recent that I've done of those projects, like my Nixie ring counter, and there's a couple of Numitron and Minitron clocks that I've started to work on, and I have a handful of other projects that I'd like to eventually do. So yeah, thank you for watching and see you later. Bye.